So we have two cars, car 1 and car 2, approach each other along two different streets. They meet at right angle and collide at the intersections. So after the clash, they entangle, stick together. So if one car has a mass of 1,400 kg, 50 kg, with an initial speed of 11.5, another car have a mass of 1,750 kg with an initial speed of 15.5 meter per second. What will be their speed v and the direction theta immediately after impact? So when a collision occurs in which two objects are stick together, we will treat the final object as a single object with a mass equal to the summations of the two individual mass, and they are going to move with a common velocity, same velocity of v. So obviously this is a 2D collisions whereby it involves the motions of x directions and also y directions. So to solve the questions, first we need to break down the velocity into x and y components. So I'm going to break down the initial velocity for car 1 into component x and component y. So initially car 1 is moving rightwards, so the component x will be 11.5 meter per second, and there will be no component y for the initial velocity car 1. How about car 2? Car 2 is, before collisions, car 2 is moving upwards with a velocity 15.5. So the 15.5 will be the component y, initial velocity component y for car 2. The initial velocity component x for car 2 is 0. So since go for the final velocity of the both car after impact, we can break it into x directions and also y directions. So along the x directions, we have Vx. Along the y directions, we have Vy. Then after we have break down all the velocity into its x and y directions, now we can write the conservations of momentum for x and y directions separately to find the missing common velocity after the impact. So for component x directions, the total momentum x before collisions must equal to the total momentum x after collisions, whereby momentum is mass multiplied velocity. So before collisions, we only have car 1 moving rightward with an initial velocity of 11.5 meter per second. So the momentum along the x directions will be 1450 multiplied 11.5. So after collisions, we have the both cars stick together, so we can treat it as a single object. So we sum up the mass 1450 plus 1750, and both of the car move along the x direction with a velocity of vx. So we can determine the final velocity along the x directions after the impact for both of the car, which is 5.21 meter per second. Then I do it again for direction y, component y. So the total momentum along the y direction before collision must equal to the total momentum along the y directions after collisions. So before collisions, car 2 is the only car that moving along y direction upwards. So we are going to have momentum, mass of car 2, 1750. So before collisions, we have car 2 moving upwards. So along the y directions, the initial velocity for car 2 is 15.5. After collisions, both cars move with a velocity Vy along the y directions. So 1450 plus 1750 multiplied Vy. So we will get Vy is 8.48 meter per second. So the V will be Vx squared plus Vy squared square root. So we will get the velocity immediately after impact is 9.95 meter per second. So the directions after the impact can be calculated using shift tangent Vy over Vx. So we have 8.48 divided by 5.21. So I'll get 58.4 degree. So refer to the component y is positive, so it's above. And the component x is positive, so it's above positive x-axis. So the direction will be 58.4 degree above positive x. Then for the second question, by calculating the kinetic energy, we need to determine the type of the collisions. So this one we are going to refer to the concept we learned in lectures, whereby how we distinguish elastic and inelastic collisions. For elastic collisions, the total kinetic energy of the system is always conserved. Conserved here means the total kinetic energy before collisions will equal to the total kinetic energy after collisions. But for inelastic collisions, the total energy of the system is not conserved, whereby the total kinetic energy before collisions will not equal to the kinetic energy after collisions. We have some loss in the kinetic energy. So how we calculate kinetic energy? Kinetic energy is equal to half multiplied mass multiplied the velocity of the object squared. So in order to determine the type of collisions, we are going to calculate the total kinetic energy before and after collisions. Then we are going to compare the value. If the value is the same, then we can draw conclusions. It's the elastic collisions. But if the total kinetic energy is not equal, then we can draw conclusions. This is an inelastic collisions. So before collisions, we have kinetic energy for car 1 plus with the kinetic energy for car 2. So we have half. The mass of car 1 is 1450. The velocity of car 1 before collisions is 11.5 squared. The kinetic energy for car 2 before collisions will be half. 1750 multiplied the velocity of car 2 before collisions is 15.5 squared. Then I get the total kinetic energy before collisions is 306,100 joule. Then I do the calculation for the total kinetic energy after collisions, after the impact. So the total kinetic energy after the collisions will be the combination of car 1 and car 2. So I have half. The total mass 1450 plus 1750. So the velocity after the collisions we already calculate just now is 9.95 squared. Then I'll get the kinetic energy after collisions is 158404 joule. So if I do the comparisons, we will find that the total kinetic energy before is not equal to the total kinetic energy after collisions. So I can draw a conclusion this is an inelastic collisions.